Okay, for item number 2, it says to consider the following algebraic functions. Here we have a quadratic and a linear, and it says to sketch the region bounded by the graphs of the functions, and also to find the area of the region. Okay, and in terms of the nature of the graph, okay, we have for the linear function, okay, where x term is positive, and we will have a line that is going to slope and upward. And with the quadratic function that is presented first, okay, we have the quadratic term is a negative x squared, and with the negative sign, okay, this signals that we will have a parabola that will open downward. And so for what we have in graphing these items, okay, first of all we can find out what the points of intersection will be between these functions. Okay, so we have setting negative x squared plus 4x plus 5 and x plus 5 equal to each other. And setting this up gradually as a quadratic equation in standard form. And we can undo the negative x squared, multiplying the whole equation by negative 1. So we can say we have x squared minus 3x is equal to 0. And factoring and using the zero product property. Okay, the values of x will be at 0 and 3. And so we have with the points of intersection, okay, so whenever x is 0, y is going to be at 5. Whenever x is equal to 3, y is going to be equal to 8. And so for what we have in the case of the setup in this one, once again, I'm not going to draw this in proportionate terms, but okay, so for what we have in the case of the graph that we have, let's say that for y is equal to x plus 5. Okay, so we'll just say we have 0, 5, 1, 2, 3, 8. Straight line passing through. And again, for y is equal to negative x squared plus 4x plus 5, okay, this will be, once again, a parabola that's going to open downward. You can use either the vertex equation or the axis of symmetry. And, okay, now the maximum is going to be whenever x, in this case, is equal to 2. Okay, and so we have, in this particular case, okay, actually the maximum in this one, the vertex will be at 2, 9. So again, we have the linear function at y is equal to x plus 5. And again, we have with the quadratic, and for the region that is bounded, okay, between 0, 5 and 3, 8, the quadratic is going to be perpetually above the linear. Okay, so we have one region, and so we can determine the area in one singular integration operation. Okay, and so we will proceed from x is equal to 0 to x is equal to 3. And again, think of the upper minus the lower, top minus the bottom. And combining like terms together. Negative x squared is going to stand alone. 4x minus x will go to 3x. 5 minus 5 will cancel. So once again, reverting to the power rule of integration, we had the antiderivatives will be at negative x cubed over 3 plus 3 halves x squared, as x goes from 0 to 3. And so for what is going to happen here, get 0, expressions go to 0 at x equal to 3. Okay, here we have negative 9 plus what is going to be 27 halves, negative 18 halves plus 27 halves is going to give us an overall area measure of 9 halves.